All right, so now moving on and understanding that quarks exist and we have 6 different flavors of it. What do quarks make? Well, now we're getting into some more language and you're gonna have to make cue cards of these things. So we have quarks, hadrons, baryons, and mesons, okay? Now we're getting some new particles. Oh my. Okay, so hadron is any particle made of quarks. Anything that contains quarks is classified as a hadron. And inside hadrons, we have 2 subclasses called baryons. Those are particles that are made from 3 quarks, a combination of 3 of them. And a meson is a particle that is made from 2 quarks. Okay, so the most common particles that you know, protons and neutrons, they're baryons because they're made of 3 quarks, as we described above. Okay, so inside the nucleus, we're really talking about baryons. All right, and mesons are a very strange particle that usually mediate forces. All right, the ones I was talking, those exchange particles, and they're only made of 2 quarks. So if I just draw a little diagram here, hadron is the overall class of particles that contain quarks, all right? But there's 2 subclasses of hadrons. You have baryons, the ones that are found in the nucleus, and mesons, which are exchange particles, okay? So in addition to that, there is antimatter, okay? So in addition, what they found is when you look inside of the atom, we found positively charged protons, and we've even found negatively charged protons, which is really strange. So we know that for every type of matter we have antimatter, a mirror image of it, an opposite mirror image of it. So the matter that we know on Earth, and Earth is predominantly matter, but there's theories that the universe is filled more with antimatter. It's just for some reason on Earth, only the matter is stable. But we can even detect antimatter on Earth, and we can even use it for imaging. So you can do a little bit of research on that. We use antimatter for imaging. So it exists, and we know how to find it, all right? But you and I are mainly composed of matter. So that means that our protons in the nucleus are positively charged, and the electrons that are orbiting are negatively charged, all right? In antimatter, the antiproton would be the opposite, so it would be negatively charged, and the electron would be positively charged. That's called a positron. We've seen that before. So electrons and positron. All right, we've seen them, so we know that they exist. So this is a hydrogen atom, and that would be an anti-hydrogen atom, which has been made in CERN, in the Large Hadron Collider. We can make it and isolate it. But the minute that those 2 meet, they would annihilate and explode and form light. Okay, they would go back into energy. So if I put that together with that and they collide, they would recombine and release a bunch of energy, and all of that matter would be converted into light energy. All right, so that might be the reason why antimatter is pretty minimal here on Earth, where we have positive matter, hydrogen. Okay, so just to summarize, all matter has an opposite version of itself called antimatter. For example, we have negatively charged protons or positively charged electrons. And what we're going to be looking at in the next video is, well, how does that happen? How can I make a negatively charged proton and a positively charged electron? Well, we'll see that in the next video.